Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I'm your instructor, Jim Herbie. In this episode, we're going to continue in Module 1 in the exam objectives by discussing Section 1.3. Our topic is Units of Measurement. Let's begin.
First, we're going to discuss different measurements we use for storage. Remember, storage is the retention of data so that we can retrieve it at a later time. The base level unit in data storage is a bit. Remember, bit stands for binary digit. An individual bit in a computer will have a value of either true or false. A true value is a value of 1. A false value is a value of 0. We use the bit as the base level unit to measure how much storage do we have available within a computer or computer system. First, we have a single byte. 1 byte equals 8 individual bits. We see a byte in our IP version 4 addresses, and we also use the byte unit when we are referencing all of the different multipliers. But just remember that 1 individual byte is 8 individual bits. Our first storage multiplier is a kilobyte. We abbreviate this as KB. A kilobyte is a data unit of 1,000 bytes. A kilobyte was the first publicly adopted data storage standard and would be in the range from 1 to 999 kilobytes. The storage that we would use with kilobytes were floppy disks. Floppy disks are an older storage standard. You don't really see them except in legacy computers. But kilobytes were introduced with the floppy disk storage media. Next, we have a megabyte. Megabytes are abbreviated as MB. A megabyte is a data unit of 1,000 kilobytes. So you should be seeing a pattern where as we go up each multiplier, it's going to be 1,000 units of the previous unit of measurement. 1 megabyte, as we said, equals 1,000 kilobytes. Megabyte storage was introduced with optical disk technologies. We've mentioned the different forms of optical disk storage. Those are CD-ROM, DVD, and Blu-ray. These 3 optical disk technologies are used with megabyte level storage. Our next storage unit is a gigabyte. We abbreviate this as GB. A gigabyte is a data unit of 1,000 megabytes. We use our gigabit storage in both our hard drive storage, USB flash drives, and RAM memory. Gigabyte is the most common data storage unit that you will see in your computers and laptops as far as the internal storage that is available on the device. Next, we have a terabyte. Terabytes are abbreviated as TB. A terabyte is a data unit of 1,000 gigabytes. It is the most common publicly available data level with the highest storage. You commonly will see terabyte storage in enterprise level hard disk drives, as well as remote cloud storage. A recently introduced storage standard of measurement is a petabyte or PB, and this will be 1,000 terabytes. This is not a commonly used data unit yet, but as we are increasing our availability of remote cloud storage, you will see this more commonly in your enterprise level cloud storage solutions. So those are the different units of measurement that we use for data storage. Now, related is our measurements for throughput. Data throughput is how much data can be transferred or sent over our network in a single second. And we use the same measurements for data throughput, but we add the calculation of bits per second. Let's go through each one. Our first data throughput unit is bits per second, BPS. This will be a data throughput or data transfer speed, where the amount of data being sent over our network is somewhere between 1 and 999 individual bytes per second. Kilobytes per second is abbreviated as KBPS, kilobytes per second. And this will be a data transfer speed that we use in our 2G networks. We also use kilobytes per second as our throughput measurement with our older dial-up internet modems. Some of your older internet legacy systems will still use existing telephone lines with dial-up modems. Any type of dial-up analog service will use the kilobyte per second throughput unit. Next, we have megabits per second, MBPS. Megabits per second is the data transfer throughput that we use in our 3G or third generation cellular networks. It is the first data throughput standard that allowed us to support streaming media. These would be services such as Netflix, YouTube, and others. The megabit per second data throughput speed allowed us to introduce streaming media as well as the ability to upload and download larger file sizes. Next, we have gigabits per second, GBPS. This is the data throughput transfer speed that we use in our 4G or fourth generation wireless networks, internet broadband, and fiber optic cabling. And lastly, we have terabits per second, or TBPS. And we use terabits per second in our most recently introduced 5G cellular networks, as well as high-speed satellite connections and long-distance fiber optic cabling. Now we're going to switch over and discuss the two different processing speeds that you want to understand for the exam. They are megahertz and gigahertz. The base unit that we use for computer processing is hertz, H-E-R-T-Z, hertz. What we are doing is we are measuring the amount of processing cycles that a CPU can do in a single second. Remember, your CPU is your central processing unit. It is the component inside of your computer on your motherboard that will handle all of the data processing of input, output, as well as file transfers and uploads. And what we are doing is we are measuring the amount of processing transactions that a CPU can do in a single second. Megahertz, which we abbreviate as MHz, is equal to 1 million hertz per second. So if our CPU has a megahertz speed of 10, that is equivalent to being able to process 10 million processes within a single second. We also can use megahertz to measure the electromagnetic wave frequencies in our wireless internet signals. So not only can we use megahertz to measure CPU speed, but we can also use it to measure the frequency of wireless internet wave signals. And our final unit of measurement in this section will be gigahertz. We abbreviate this as GHz. And gigahertz is equal to 1,000 megahertz, or the equivalent of 1 billion processing cycles per second. Gigahertz also allows us to measure the same frequency in our wireless internet signals. If we are operating at the gigahertz speed, this is going to be high-speed data transfer, as well as extremely high internal data processing speeds. We use gigahertz to ensure that we have accurate computer time clocks, as well as to calculate all of the different data transactions that we do within a single second for our CPU internal data speed.
That will conclude our discussion of Section 1.3, Units of Measurement. In our next episode, we will move on to Section 1.4 in the objectives, and our topic will be troubleshooting methods. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.